Let us understand how to aggregate the data using SQL. We can either perform global aggregations or aggregations by key. Global aggregations are also known as total aggregations. Here are some of the examples with respect to global aggregations. The first one is getting total number of orders from orders table, then getting revenue for a given order ID from order items table. Another example is get number of records where order status is either in completed or closed status from orders table. These are all global aggregations or total aggregations where we are trying to get the count or sum or min or max on a particular column from a given dataset. There can be conditions if you want to filter out the data which you are not interested in. Now, when it comes to aggregations by key, we typically use group by clause. Here are some of the examples with respect to aggregations by key. The first one is get number of orders by date or status. Either you can group by date to get number of orders by date, or you can actually group by status to get the number of orders by status. Another example is get revenue for each order ID. Order items have data related to approximately 50,000 orders, and if you want to get revenue for each of those orders, you can actually use group by order ID, and you should be able to compute revenue for each order ID. Then another example is getting daily product revenue using order date from orders and product ID from order items as keys. So this is nothing but an example for joining two tables, orders and order items, then grouping by order date from orders and product ID from order items, and then use order item subtotal to compute the revenue for each product for each day. If you want to filter on top of aggregated results, you can actually use having clause and apply filters. Example for such kind of use case is get daily product revenue where revenue for each day for each product is greater than $500. In this case also we'll be using order date as well as product ID as keys, and then we can actually say sum of order item subtotal is greater than 500 after grouping by the date as well as the product ID. There are certain rules which you need to follow while using group by. We can have the columns which are specified as part of group by in select clause. However, if you want to skip some of the columns which are specified as part of group by while projecting in select clause, you can do so. But you can only specify those columns that are specified as part of the group by clause, or you can have derived columns using aggregate functions. You cannot have any other columns that are not used as part of group by or derived column using non-aggregate functions. So if you have functions such as substring or upper or lower, etc., which are not non-aggregate functions, you will not be able to use those things when you use group by as part of the select clause. We will not be able to use aggregate functions or aliases used in the select clause as part of the where clause or even group by clause. Examples for this statement are these ones. So you can see here I'm trying to specify the sum as part of the where clause, which is not valid. You cannot even use alias revenue as part of the where clause. Even that one will not work. So you have revenue here. If you have revenue as part of the where condition, which is nothing but a alias for one of the functions that are used as part of the select clause, it will not work. If we want to filter based on aggregated results, then we can leverage having on top of group by, specifying where is not an option. Now let's understand typical query execution. Even though the query is written using select clause first, then from clause, then where clause, then group by, so on and so forth, when it comes to order of execution, it will try to read the data from the tables that are specified as part of the from clause. Then it will apply filters that are specified as part of the where clause. Then if there is group by, it will try to group the data using the keys that are specified as part of the group by. Then if you have having, it will try to filter the data using having. Then it will go to the select clause. So select clause will be used last to project the data. However, if you have order by will be later than select clause. Up to group by and having, this is the order. If you have order by, after select, order by will kick in. The reason why you need to understand this is because select will be used after from, where and group by. Whatever aliases that are specified as part of the select clause will not be visible for you as part of the where or group by, or even having if you have having as well, because if you have having, even having will be executed before select. You need to understand this query execution so that you imbibe the rules when it comes to using group by as part of your queries. Now let's connect to the database and let's get the number of orders in orders table. There are 68,083 orders. However, if you want to get distinct values on a particular field and if you want to get the count, this is how you can actually get the count. In this case, you can see that there are 364 unique dates in our orders, and you can get this 364 by using function like this, count of distinct space order underscore date. Now if you look at the items for order ID 2, there are 3 such items. Even getting order revenue for a order ID 2 is also considered as a global aggregation or total aggregation, because we are not using group by here. Now you can see the revenue for order item order ID 2. However, it might give you more than 2 decimals. To round it off to 2 decimals, you can use round function like this. When you use round function, you might have to typecast the order item subtotal to numeric like this. Otherwise, it will not work. Now, this is what will give us the number of orders whose status is in either complete or closed. It is also example for total or global aggregation. This is an example for aggregation by key. In this case, the key is order date. So we are trying to get number of orders by date. You can see the results here. For 2014 July 17th, the number of orders is 162. It's better to have order by so that we get the same results, and it will facilitate us to compare and validate that our queries are right. Now you can see that the data is sorted in ascending order by date. This will give us the count of orders by status. This is also example for aggregation by key. Here also I'll be ordering the data by order status so that we can easily compare results. Here is the count by status from our orders dataset. Now if you run this query, it will try to get us the revenue for each order ID from order items. Let me run this. You can see the revenue for each order ID from order items. However, for some of the records, the decimals are beyond 2 digits and I want to round it off to 2 digits. If you try to run this query, it will fail because order item subtotal is of type float and the round expects it to be double precision. To convert the float to double precision, what you can do is you can typecast the output of sum to numeric. In this case, it will take care of typecasting the output of sum to numeric, and you should be able to see the results with only 2 decimals for all the records. Using round function with 2 as the second argument, we can achieve this. Now let's get daily product revenue by joining orders as well as order items. This is how the join condition look like. And then using where we are trying to filter for complete or closed orders. Then using group by, we are grouping data by orders or order date and order items order item product ID. As part of the select clause, we have round off sum of order item subtotal comma 2 to get the revenue for each date and for each product. This will give us the revenue for each date and for each product, which is nothing but daily product revenue. Now if you want to just get those products every day whose revenue is greater than $500, then you cannot specify the condition as part of the where clause like this. So you have the alias revenue, which will give us the revenue for each date for each product ID. We will not be able to leverage that revenue field as part of the where clause because the order of execution is first it will try to fetch the data using the tables that are specified as part of the from clause. Then it will try to apply where. When it try to apply where, as select is not executed yet, it will not let us use this alias or even the function. Even if you try to use the aggregate function as part of the where clause, in general SQL syntax restrict that you cannot specify aggregate functions as part of the where clause. That's why when we run this, it will fail. It is saying aggregate functions are not allowed in where. When it comes to the revenue, it is saying column revenue does not exist because the aliases that are specified in the select clause are not visible as part of the where clause. So either of these approaches are not options. If you want to filter on top of aggregated data, the formal way of filtering the data after performing the aggregations using group by is using having clause. So as part of the having clause, you can actually specify the aggregate function like this and you can apply the filter. In this case, I'm trying to get only those daily products whose revenue is greater than 500. Now let me run this. I want to sort the data by order date and then revenue DESC. So when it comes to order by, you should be able to specify the aliases that are mentioned as part of the select clause because order by typically executes after the select clause. So the order of execution is first from clause, then where clause, then group by, then having if there is having, then select, then order by. Because order by executes after the select clause, you can specify the aliases like this. Now you should be able to run the query and validate your results with my results to ensure that we both are getting the same results to get daily product revenue considering only complete or closed orders, and also where the revenue is greater than $500. If you want, you can actually try to display 25 records, and you can see that after 599.99 for 2013 July 25th, it went to 2013 July 26th, because there are no other products which have generated more than $500 revenue on 2013 July 25th. We can also get counts to actually compare the results with or without having clause. So in this case, I am getting count without having clause. We have 9,120 products which have the revenue for each day. Now when I have having clause, this is how the results look like. There are only 3,339 records which have the daily revenue for each product where the revenue is greater than or equal to $500. So this is how you should be able to validate the query results and understand what is going on internally. So that being said, this is how you can perform the aggregations. The aggregations can be total aggregations or global aggregations, or it can be group aggregations using group by. If at all you want to filter on top of aggregated results after group by, then you have to use having clause using where is not an option. Keep that in mind. It is very, very important, because many of us make silly mistakes by specifying the aggregate function as part of the where clause or the alias as part of the where clause to filter the data further. That will not work.